Hi, welcome back to the session of IC fabrication process. This is session 5. Till now we have discussed in the last session about NMOS fabrication steps. We will continue further in this session about CMOS fabrication steps. Now before proceeding further, let us first have a look on the CMOS circuit diagram. If we see the 2D view of CMOS, we can say that there are inside the P substrate there is one N well. Then here are the two doped regions, that is N regions, which form the NMOS here, and there is one P plus substrate, and inside the N well there are two P regions with one N plus doped regions to form the PMOS, right? And then we connect the gate of NMOS and PMOS together. Then here these two terminals will be connected to the supply region, the source and substrate of this PMOS. Then the drain of PMOS is connected to the drain of NMOS, and the source and substrate of NMOS is connected to the supply VSS of ground. Okay, so this is what we want to fabricate now, and we will see the fabrication steps. But before that, let us have a first look on the 3D view of the CMOS, that how basically it looks like. Let's see this, that what are the different layers inside the CMOS. Then we will see that how basically we will form this structure. Okay, so we can see here that inside this PMOS substrate there is one N-well region. These are the doped P plus regions, drain, source and N-well cut. Here is the gate, then here are the drain and source regions for NMOS transistor with P plus substrate connection. And you can see that here is a contact cut over which metal is poured, which can be extended further for connection. Here you can see that here this is the thin oxide, gate oxide, onto which polysilicon is there, and this polysilicon gate is extended further, and this gate is connected to this gate, right? You can see here that this drain metal is poured through this contact cut, and this drain metal is poured through the contact cut, and these metal lines are meshed together to form this connection of drain of MOSFET. PMOS is connected to the drain of MOS. Okay, and here this source and substrate, these two are connected together with metal connection, and they will be connected to ground for the NMOS, and for the PMOS these two regions are connected together to connect it with the supply voltage VDD. Okay, so this structure we need to form. So from where should we start? We have already discussed that we have fabricated the wafer, that means this P substrate we have already formed. Now what should be the first step? The first step should be the isolation. That means the areas, these areas where we are not going to fabricate anything, and the middle area where is nothing is fabricated. So these areas must be isolated with thick oxide layer. Like this is the CMOS. So these two areas and the middle area must be covered with thick oxide. Okay, and the very first step after this should be the N plus region, N well region. Okay, when we will form N well, then we will have two separate areas. Here inside the N well you can create a PMOS, and outside the N well in the substrate you can create NMOS. Okay, so let us see the steps one by one. The first step for CMOS application, we will start with the blank wafer, and our aim is to form the N well. That means we want to form this structure. Okay, so now from this basic P substrate to form this N well, let us see the steps. The first step is to form the N well. Now the sub steps are, we will discuss. Okay, cover, first of all we will cover the wafer with protective layer of SiO2, as I said to you few minutes before, that first we should cover with the thick oxide. Remove layer where N well should be built. Okay, implant or diffuse N dopants into exposed wafer and strip off SiO2 from the areas where it is not required. So first step is oxidation. We will grow the thick oxide layer onto the surface. You can see here that we have grown over the P substrate the thick oxide layer, okay, onto the entire wafer. And as I said to you in the past, that the operation may be dry oxidation or wet oxidation depending upon whether you are reacting with H2 or O2, okay, at a very high temperature. So finally oxidation takes place and thick oxide layer is grown. Now we will cover the thick oxide layer with a photoresist. You can see here, photoresist is a light sensitive organic polymer, softens when exposed to light. We have already discussed these points in the last CMOS fabrication session. Okay, so the purpose of depositing the photoresist layer here is the lithography. That means we are patterning, we are going to remove this oxide from some portion and we want to keep it at some places, right, for the purpose of next stage, that means anvil development. Okay, anvil creation. So lithography is done where we want to create the anvil. We will put the mask over the surface and we will expose it to the light so that we can remove the soluble photoresist from this region and we can etch away the silicon dioxide also from this region. Okay, so we get this shape here. Now we can dope n atoms for the purpose of anvil creation. Either diffusion is more suitable in this case or we may do it with ion implantation. Okay, then first of all we will strip the photoresist where it is not required, and during this anvil implantation process this SiO2 will work as the isolation layer. Okay, so now we can dope and we can form anvil either using diffusion or implantation, and then we can strip the oxide. We can strip the oxide from the whole surface if we want, or it is better to keep the oxide at some places just in between and at the corner to avoid to isolate it from the other near CMOS inverters. Okay, so I have just removed this in this diagram all over the surface, but actually we will keep it in the center and in the corners. That will be shown in the next figure also that will come. Okay, so next step is what? After this thick oxidation and this anvil, the next step is to grow the thin oxide layer to form the gate and polysilicon patterning over. Okay, so we will deposit very thin oxide layer over the surface and we will cover it with the polysilicon. This is something similar to what we have already done in CMOS fabrication also, right? So now we will again do the lithography process and we will keep polysilicon thin gate only at the required gate area for the for where the we will fabricate the gate of NMOS as well as PMOS, these two reasons. So we will again place a mask, we will do the patterning using lithography process and we will finally achieve this polysilicon and thin oxide on two regions where we want to fabricate either the gate for the NMOS or the PMOS. Okay, thick oxide is also there here in between and at the corners. Now the next step is what? N diffusion or P diffusion. Anyone can be taken first. We are first diffusing N region, so that means we are depositing N region here and here to form the NMOS, and also here inside the N well to form the bulk substrate connection for this N well. Okay, so pattern oxide and form N plus regions. For that again we have to deposit the layer and we have to create a mask, and using the same set of lithography, using the same set of process, we will finally cover with the photoresist. Then we will dope finally the N plus regions where we want to form the NMOS or the substrate connection. Now the next step is to strip off the oxide to complete patterning this. Okay, finally we will get this one. Next, the next step is again in a similar manner we have to create the PMOS and P plus substrate region. So PMOS is created here and P plus region is required to be created here. So we will do the same steps again to form the PMOS and P plus substrate connection. Okay, that means again we will cover with the photoresist, the lithography, we will diffuse the atoms or ion implant and then we will remove the covered layer. Okay, so P diffusion, similar steps, and finally we will get P plus and P plus. So this is the structure we have created. Now what is the next step? The next step is to cut, to make contact cuts where metal can be poured and can be further extended for metal connections. Okay, so connection is required for this N plus region, this N plus region, this P plus region, this P plus region, P plus region and N plus region. So we will again do the process in the same manner. That means we will first cover it and then we will pattern it. Wherever we need contact cut, there we will etch away the material. Okay, so now we need to wire it together to the device. We will cover chip with thick field oxide, H oxide where contact cuts are needed. Again we are covering in that manner, and then finally we get the contact cut, and then we will pour metal over them. Okay, so the next step is metallization, which can be done either sputtering is a well known method, and there are other metal deposition methods are also. So we will cover the layer with the above metallization, and we will remove the pattern to remove excess metal. Okay, so finally we will get the metal layer over this. We will remove the excess material deposited, and we will keep only the metal where it is required, and then we will further proceed to metal connection. We will extend those lines wherever it is required. Okay, so in this manner, for example, this metal is connected to this metal, this is forming the drain to drain connection, right? These two are connected to form one connection where we need to connect it with the VDD supply, as we have seen in the starting, and these two are connected together to connect it with the ground or bases. Okay, so the next step is simply passivation. That means we will cover the wafer with overglass. We will cover it with overglass for the purpose that it prevents shortening due to dust particles, etc. Makes finished wafer easier to handle. And then what we do, we etch that overglass from some of the area so that small wires can be extended further for connection. Which connection? This we have already discussed. There is a core and there is a die. So what happens that from those small areas we take the wire which connected with this from die to core to the pins which are connected to the external wire. Okay, so edge over glass from some areas for bonding pads. So in this manner, finally we get our required CMOS inverter. So this is all about the CMOS fabrication steps in brief, to give you an idea how basically CMOS is fabricated, and these steps apply for everything. In a manner, I want to say that, as we have already discussed, that all the operations take place onto the complete wafer, right? Onto the complete wafer all the operations take place, and we have already discussed that inside the wafer there are a number of cores and dies, and inside one core there are a number of MOSFETs. So all the operations are taking place onto the entire wafer. So all the methods which we have discussed for CMOS fabrication or NMOS fabrication are basically applicable for complete fabrication steps for the complete chip we are manufacturing. Okay, only some system will vary. Okay, that which step will be followed in which manner, and there will be more sub steps, but the basic steps will remain same. So this is all about what are the main or major steps in IC fabrication. In the next session, which will be the last session for this IC fabrication, I will discuss in detail about the major steps like photolithography and others, है ना? So up to metallization and packaging. So these all steps I will discuss in little bit more detail in the next last session. Till then, thank you.